Okay, it is 2 minutes after the hour. I will go ahead and get started. And first, I want to just do a quick introduction. Thanks everyone for joining. I am Brad Schmidt. I'm a solutions architect with New Relic. And in today's session, I'm going to be discussing how to upgrade your Kubernetes observability with Pixie. You may have heard of Pixie. We're excited about it. And so this session is really geared toward giving you an overview of Pixie's solution and how we're leveraging it within the New Relic platform. And then there are some other Pixie-related sessions throughout the day, which I'll direct you to at the conclusion of this session that I think you might be interested in as well. So let's go ahead and get started. We've got about 50 minutes in this session, and I want to make sure we have enough time for maybe a couple questions toward the end. Before we get going, though, I do have to say we may get into some roadmap-specific questions or topics during this session. So this is just a safe harbor slide stating that sometimes things change, priorities change, and so anything roadmap related, it could potentially change in the future, but hopefully we won't get too far into roadmap specifics in this session today. Let's talk about the agenda. We are going to cover New Relic observability for Kubernetes to start off with. So what solutions make up our offering? How do you leverage them in the platform? And what do they do? Second, we're going to introduce Pixie. So Pixie is a solution that leverages EBPF for its telemetry acquisition. And you may not be familiar with EBPF. So we'll talk a little bit about what it is, what it does, and how we leverage its capabilities in our platform as part of Pixie. And then I'll be showing a live demo. And what we've done for Data Nerd Days is we've created a demo account that you can actually log into and kind of poke around and play around with yourself, while I'm talking through some of these topics, or even after the sessions are over. We'll leave this account open for about 24 hours, and that'll give you some access to the demo cluster that I'll be showing. Looks like the hop-in kind of messed up my formatting there, so apologies, but you should have a URL to one.newrelic.com. You've got a user of Data Nerd Days at sharklasers.com. I wish I owned that domain, but I don't. And then a password to log in. So feel free to use that as we get further along here. And then hopefully I'll leave some time for some Q&A at the end. And then I've got John, my moderator, paying attention to the chat as well, and he can help me out. All right. So I mentioned the demo account. We'll leave it up for 24 hours, and you have access to all the data that I'm about to show you. So let's go ahead and jump in. Observability for Kubernetes. What does that mean at New Relic, and what capabilities do we have in our platform? First, starting at the top of this slide, we have an awesome Helm chart. We call it NRI Bundle. It encompasses multiple different subcharts that you have the option to install into your cluster. We also have a guided installer in our UI, which I'll show following this slide. But essentially, our Helm chart gives you the ability to collect telemetry from certain areas of your cluster for various different purposes. So starting left to right, we have an infrastructure agent that's deployed as a daemon set to the cluster. It collects performance metrics, status, and other important things around your Kubernetes resources and cluster nodes. We also have a Kubernetes events integration that's part of this bundle. It collects your cluster-wide events and gives you visibility into either resource contention, maybe there are pods being evicted, maybe you've got scenarios where containers aren't starting for some reason. Those things can surface themselves in Kubernetes events, and that gives you quick and easy access to go out and remediate those issues. Prometheus metrics. We have a lightweight Prometheus scraper that allows us to collect data, collect metrics from your Prometheus endpoints that are exposed in your cluster. So this can be deployed to the cluster And we have a number of customers leveraging this to bring additional metrics into New Relic, like, say Nginx ingress metrics or core DNS metrics, as an example. We also have a logs integration. It is Fluent Bit, pre-configured to ship container logs to New Relic. It runs as a daemon set in your cluster and gives you visibility into all of the logs coming out of any of your containers running that are part of your microservices. And finally, on the far right, Pixie is now a component of our Kubernetes solution. And it provides you observability using EBPF. It gives you visibility into HTTP requests, database calls, and network metrics using EBPF without actually adding an APM agent to the applications running in your cluster. This is also deployed as a daemon set, and it runs on each of your cluster nodes. I mentioned the guided installer. We try to make it quick and easy for you to get up and running with our Kubernetes solutions. You have the option to select either enable or disable the components that I just mentioned in the previous screen. And then we give you a Helm install command. And there are some other prerequisites that we package in there. There are some CRDs for Pixie that are part of that. But essentially, we try to give you this easy copy and paste, drop it into your terminal, and you should be up and running with your Relic and Pixie shortly thereafter. So let's get into some of the Pixie specifics. So Pixie is open source observability. New Relic acquired the Pixie Labs team and solution back in December of 2020, I believe is when it was announced. And we worked with Pixie to donate Pixie to the CNCF. So that was donated back in June 2021. It will remain an open source CNCF sandbox project. It is active, very active. And we just got back from KubeCon and met with a number of fantastic customers there. And some of the capabilities that it brings to our platform is the ability to visualize service connectivity and performance. So being able to understand, which services are calling others in the cluster and drill into those and maybe do some deeper dive investigation there. Pixie brings always-on profiling to our platform using Flamegraphs. So for compiled languages like Go and C++ and Rust, we have the ability to look at resource consumption of a node or other Kubernetes resources in the Pixie solution itself. And I'll show an example of that in the demo. Pixie is also able to collect full body application requests for applications using HTTP, HTTP2 or gRPC if you're using Golang, and they are unsampled. So this data actually lives in memory in your cluster. It's stored for a short period of time. We say typically 4 to 24 hours, but it gives you unsampled access to those calls happening between services in your cluster. And that can be super useful for troubleshooting your applications. Now, Pixie and New Relic, we've actually built an integration with Pixie, and we are able to bring some of this data into our platform. We do that in a number of ways and present it in a number of areas, but the highlights are we're now providing you a live debugging tab in the Kubernetes Cluster Explorer. This gives you direct access to that data that sits in your cluster in the Pixie solution. So quick and easy access through that tab. We ingest HTTP requests via span and metrics into New Relic for longer term storage. We give you the ability to dashboard off of that data just as you would other New Relic telemetry in our platform. And also we allow you to alert off of those metrics as well. So Pixie does not have any native alerting capabilities, but with our integration, we now give you the ability to alert when, say, latency exceeds a certain threshold, or maybe you have a spike in errors. And then also at the very end of the demo, I'll show an example of how you can leverage some of this Pixie data in a feature called workloads in New Relic, just as another example of how we're using this data throughout our platform. And I've provided some links here if you want to learn more about Pixie. We'll make this deck available after the presentation. So let's talk a little bit about the Pixie architecture. So what are we deploying to the cluster? How does it work? How does it fit together? So this is a high-level diagram of the Pixie solution. Starting on the left, you'll notice that we've got a cluster, and we've got multiple nodes running in the cluster or as part of that cluster. And you have services that are running your applications or sitting in front of your application pods. We deploy the Pixie Edge module as a daemon set. It's responsible for deploying either kernel probes or user probes to those nodes, and it sits in your Linux kernel. So it's able to see and trace protocols like HTTP, DNS, MySQL, Postgres, and others that we'll get to later on in the presentation using eBPF. And it does this without APM agents or infrastructure agents. So it sits lower level in your node, and it ships that data over to the Pixie Vizier. This is a combination of multiple components. It involves NATS, which is a messaging service. We have a metadata service, which kind of collects cluster metadata like pod names and IP addresses. And then the query broker facilitates queries to some of the various Pixie components. And then you access this Pixie data through our live UI, through New Relic in the live debugging tab. And Pixie also has a CLI that allows you command line access to this data. So you can actually script calls to the data that sits in the cluster with the Pixie CLI. And I'll show a simple example of that in the demo as well. So I mentioned EBPF. Maybe this is the first time you've heard of it. It stands for Extended Berkeley Packet Filter. And it's been around for a little while. It started in the networking space, but we've seen use cases for it in security and now observability and tracing. There are a number of CNCF projects that leverage eBPF. Some of those you may be familiar with in the slide. There are various SDKs that allow you easier access to run eBPF programs in the kernel. But what we are most interested in, at least for this presentation, is understanding how this works and how it relates to application observability. So eBPF essentially allows you to run sandbox programs within the operating system using a just-in-time compiler. There is a verification engine that ensures safety and efficiency of those probes that are running. So it's extremely safe, it's secure. I've provided a couple links at the bottom of this slide that goes into great detail about how that's done. But just know that this is well protected and well regulated, within your cluster nodes. And then we have the Pixie components themselves. So I mentioned the Pixie Edge module. It's deployed to the cluster node, and it's responsible for deploying these BPF probes, which are triggered on various system calls happening within your Linux kernel running in your cluster. So we can see things like DNS and HTTP. Kafka, for example, is another protocol that Pixie is able to trace. And the probes then send that data back up to the Pixie Edge modules, where that data is parsed and stored, and then you can visualize in our UI. So I mentioned some of the protocols. I have a full list later on here in the presentation. But before we get into the demo, or before you go to deploy Pixie to your cluster, it's probably helpful to understand, is my cluster supported, and what protocols are actually supported that I might be able to see, if you deploy Pixie for some of your services. So on the left-hand side, we have some of the prerequisites: Kubernetes version 1.16 or newer. EKS, AKS, GKE, self-hosted, and Minikube are all very well tested. We've seen success on OpenShift and some other platforms as well. If you don't see something in the list, that doesn't mean it's not supported. It just means that it hasn't been fully tested. So if you have a supported Linux kernel, version 4.14 or later, and you've got the necessary version of Kubernetes, 1.16 or later, and you're running an x86-64 processor, then more than likely you'll have success deploying Pixie to your cluster. There are a couple caveats. Currently, we're recommending about 2 gigs of memory per node as a prerequisite. And the reason for that is that the Pixie's data is stored in memory. We're working to reduce that as part of the roadmap for the rest of the year. And then also there's a current soft limitation of about 100 nodes per cluster, which we're looking to extend to 300 nodes per cluster, and then ultimately up to at least 1,000 nodes. So these are known issues, we're working on them, but just wanted to be upfront about where we're at with some of the prerequisites today. On the right-hand side of this slide, we outline the protocols that are supported. So regardless of the languages that your services are built on, if they're leveraging HTTP, DNS, MySQL, Postgres, just as some examples, then we can give you the ability to trace those protocols with Pixie, and you'll see examples of that in the demo as well. So I've provided links to both the prerequisites and then the supported data sources that are available today. Kafka was just recently introduced, so there we can see consumer lag and give you visibility into some Kafka telemetry using Pixie. And now we will go ahead and transition over to the demo. So I'm going to go a couple different directions with this demo. First, we're going to dig into the cluster data that Pixie is able to collect using EBPF. So we're going to dive into that live debugging tab that I mentioned. And then for the second part of the demo, we're going to come back up and we're going to investigate, some of the Pixie telemetry that we've shipped to New Relic's platform and show you, how we're using that data in various places and UIs that we have available to you. So when you log into that demo account, you'll probably see a screen similar to this. And actually, let me zoom it in just a little bit. So I've got a few things favorited for you already. I've got a workload and a Kubernetes cluster. I've also favorited a view which focuses on the Pixie open telemetry services themselves, all of which I'll touch on. But first, I'm going to go into the Data Nerd Days cluster. So this is our Kubernetes Cluster Explorer. I won't go into every area of this for today's demo. If you're new to this essentially gives you cluster status. So we have 2 nodes in this cluster. We can look at resource consumption of those nodes. I have some slide outs to give me deeper visibility into certain areas, so CPU, memory, storage, and running pods. And then kind of moving from the outside of the visualization to the middle, we've got pods that are running in the cluster. So this will show me pods that are either running, alerted, or in a pending state. And as either maybe I'm an SRE or maybe I'm an application developer, either way, this gives me the ability to investigate potential issues in the cluster. On the right-hand side, you'll notice related entities. So this visualization, there's a lot of things packed into it. So I can see that I have 21 services that Pixie is able to see. And if I hover over this red one, I can see that my orders service I currently have something in an alerted state, which we'll show in just a minute. And then I've also got other entities that are related to Kubernetes. So deployments, daemon sets, stateful sets, pods, and it's running on 2 hosts. So this gives you the full view of this cluster and everything that's running in it. And then at the bottom, let's say I wanted to search for a specific pod name. We give you a search here a little bit lower down on the screen. We'll come back to this though. I want to jump straight into the live debugging tab for purposes of the demo. And we'll start with the service graph that is about to pop up here. First off, you'll notice this dropdown, the script dropdown. Everything in Pixie is driven by Pixel scripts. So I've pulled up a GitHub repo. This is a community repo. It's out in Pixie's GitHub site here. And it's a collection of scripts that do various things. They collect various types of telemetry. So you'll see a rather large list of things like HTTP data and just a cluster overview script. I mentioned Kafka as one of the protocols that we're able to trace. MySQL, so on and so forth. So each of these scripts is able to go out and acquire telemetry from the cluster and bring it back to you, whether it be using the CLI or the UI. And these are open source. We welcome contributions as well as updates to these scripts, so feel free to check these out on your own time. But this is essentially how this UI is driven. We are selecting those scripts. They are going out and acquiring telemetry and bringing it back to us. So you can see here, I'm in the cluster script. I get a service map overview of the connectivity between the services in my cluster. I can interact with this. I can see that I've got some load generation running here. It's connecting to my sock shop front end, and then from there, the front end is making calls out to various other services in the cluster. I can sort this by error rate. So currently I'm seeing just over 1% error rate between the load test and the front end. If I hover over this red line, my order service has a significantly higher error rate, so just over 10%. Or I could look at this just by latency. So everything's performing well, but I've got some issues with errors in there. Continuing on through this dashboard, though, we show you things like nodes and namespaces and counts of pods and namespaces and node resource consumption. And then also services running in this cluster and their latencies, error rates, throughputs, inbound connections. So you can kind of start to understand how things are connected, how they're performing, and what's actually running in your cluster all in real time. Notice that this just since 5 minutes ago. So this is all live data in the cluster. So let's go ahead and dive into this data a little bit. Let's say maybe I'm a Kubernetes administrator. I have high CPU on one of my cluster nodes, and I'd like to go try to understand that a little bit better. So I can drill into my node here, and I get a different script. So notice that the script has changed to px node. I get my node IP, and then I have the option to group by node, service, pod, and namespace. Let's go ahead and just group by service. And this UI will repaint. And now I can start to see, okay, some of the highest consumers are, in fact, the front end and some of the load gen happening in the cluster. Scrolling down, I can see, bytes read and written, network traffic. I can see resident set size from a memory perspective. And then I get to the flame graph. So I mentioned the flame graph in the presentation. This is a representation of all of the activity happening on this specific cluster node. So starting from the bottom, you see this segment that's called all. And then one step up, I see namespaces. So I can group this by namespace. Sure enough, my sock shop namespace, which is where my demo application is running, is consuming about 33% of the CPU over the past 5 minutes, and I can see actually how many samples are make up this aggregation. And what this allows me to do is, as either a cluster administrator trying to understand which application teams I can go speak to about some resources they're consuming, or maybe I'm an actual developer responsible for one of these applications. I have the ability to drill into this detail and look at some of these flame graphs in a little bit closer fashion. So you can interact with these charts. I can zoom in on orders. Maybe I've got an issue with my Node.js app, and there are some functions in here that are performing slowly. This gives me the ability to not only shift from cluster consumption, but get into some of the always-on profiling that the Pixie is able to give us visibility into. So that's kind of one troubleshooting workflow from a node or infrastructure perspective. We are working to improve language support in the flame graphs. Java and Node.js are part of the roadmap, so you'll see improvements there, and these flame graphs will become more complete. But it's an always-on profiler, very useful, especially for those compiled languages like Golang, C++, and Rust. I'm going to zoom back out to the cluster overview. And now we'll go into a namespace. So, I might be the developer of the sock shop, or maybe I'm responsible for one of the sock shop services. I've drilled into that namespace. The service graph has repainted. So now I can actually filter out a little bit of the noise, and I could see connectivity between the services that make up my sock shop application. Here's a list of services, latency, error rate, and throughput in this table. and then the list of the pods that are currently running in the cluster and resources they're consuming. I'm actually going to generate some errors here, and I don't want to steal too much thunder. There's some other sessions that will actually walk you through the process of diagnosing errors and getting into some of the details behind, why an error might be occurring and finding root cause. But you can see that I've got this sock shop front end. I'm trying to do some filtering. The UI is not responding the way I would expect. I'm trying to get the catalog to respond. It's not working. So let's go ahead and drill into the catalog service. Sure enough, I see a spike in errors. That's interesting. So Pixie's already identified that some errors have been generated. In the service itself, I can see my golden metrics, response time, errors, throughput. And then I can also see the list of pods related to that service. Now I only have one sitting behind this service, but this could be a list of many pods. I can see where the traffic's coming from. So I have some load generation running in this cluster. It's coming from my front end service to the catalog. And then I can also view slow requests. So this is the 99th percentile for this service. And I can sort this by latency. So maybe if I wanted to find the slowest request in the last 5 minutes, I'm able to do that. And I mentioned the ability to see full request bodies, headers, etc. So using EBPF, running in the Linux kernel, we're now able to see some of this application data in real time in great detail. And that's extremely useful, especially if you're trying to troubleshoot, certain errors that might be occurring, or even just looking at some of the responses that are coming back from your applications. So this is the PX service script. I could go further into this. I could go into the pod. Maybe there's a specific pod that's giving me some issues. And I can see processes running in that pod, the containers and their container IDs, the same resource utilization metrics here at the top, latency, error rate, and throughput. And then if I get to the bottom, we have a flame graph again, but this is scoped to just this catalog pod. This is a Golang service, so I can now see some of the activity that's happening. Maybe I've introduced a recursive function that's consuming a ton of CPU. You would see that reflected here in one of these wider segments, and I would as the owner of this application, this data would be super meaningful to me, and I could easily spot issues using the flame graph. So that was kind of a secondary approach to leveraging Pixie to troubleshoot issues from a namespace or more of an application perspective versus a Kubernetes infrastructure perspective. Now, in the presentation, I mentioned not only do we get observability from Pixie for things like HTTP, but we also get visibility into things like network. So we have a net flow graph. I need to specify a namespace. So we'll look at the sock shop, and now I can see the network connectivity between my pods and the various Kubernetes services that they're making calls out to. So here's the load test going to the sock shop front end. I've got RabbitMQ in here making calls to a RabbitMQ service. And then if I scroll down, you can see bytes sent and received, total bytes from those pods to those services happening in the cluster. So this is just an aggregated view of some of that network connectivity. And then we give you filters at the top. So maybe you wanted to filter down to some of just the higher throughput services as part of your troubleshooting process. DNS. So DNS can be a tricky issue to diagnose in Kubernetes. And there are some interesting things that tend to surface in clusters in this Pixie data. So I can see, I've got really two groups of things here. I've got core DNS making calls out to my DNS server in my VPC in AWS. But then I also have some of the various services running in the cluster calling kubedns. So let's say you were experiencing some slow response or had complaints about slowness in one of your services. It could be DNS related. And this is a quick and easy place to drop into Pixie and view how many requests are occurring, what the average and maximum latency is for those requests. And then we also summarize that here at the bottom as well. So where's it coming from? Where's it going to? And then, is there some latency? And that might be something that you would want to do some further investigation into. There's also some pretty useful scripts out here for things like external fully qualified names. So is it easy to answer the question, what calls are leaving your cluster? Where are they going? How often is that occurring? So we're able to provide you a list of those calls. You can see some of the calls going out to New Relic here. And if I drill into this, I can see that I have some resolution issues. So some of these are not being resolved. This is related to a common problem in Kubernetes called NDOTs. I won't go into detail about that issue. There's plenty of blogs and videos, but essentially what's happening is before this call is sent externally, it's making a lot of internal calls, and those are failing. They're not able to be resolved, and we're able to surface that here using this script. As you can see, there's a ton of scripts here, a ton of ways to look at different aspects of your Kubernetes cluster and the services running within them. I'll go ahead and wrap up the deep dive into Pixie data just by looking at this HTTP data filtered script. So this gives me direct access to that unsampled data that Pixie is acquiring using EBPF. If you recall, I generated some errors using the SockShop front end. So if I pop open my developer tools, I'll show you an example of what we're doing here. So if I apply this, it's gonna either post or run a post or a get out to my application. In this case, what's happening is there's a database connection error, and I'm getting a status code of 500. Now, this might be obvious to me. Maybe I'm debugging my application, but imagine if you had thousands of users hitting this issue or experiencing a fairly wide breadth of response codes from the app. You would want to know about that and have the ability to drill into that data. So I just generated those 500s. We can see that here. So I quickly filtered to 500. This could be 404, 406, whatever your applications might be generating. But this gives me, direct access to those responses coming back from the application, and then I can take this information elsewhere. And maybe I want to go investigate the database in this case, which we can do with MySQL or Postgres using Pixie. So I'll stop there because I think some of the other sessions today are going to get into a few steps deeper into this troubleshooting. But I just wanted to help illustrate the level of detail that Pixie is able to present using EBPF running in your cluster without having to instrument all of your application instances with an agent itself. So let's kind of zoom back out a little bit. I've spent a decent amount of time in the live debugging tab. I did mention the CLI before I leave here. There is a CLI you can install. It allows you to run these scripts from the command line. You can pull them back. It'll output the data in JSON if you want, and then you can use that for automation or other purposes. But I encourage you to check out the CLI once you get Pixie up and running in your cluster. So let's zoom back out a bit. We do provide some kind of quick links or quick access to certain scripts. So we've kind of called out some of the network monitoring aspects of Pixie here. So you've got some slide outs for things like spotting those DNS issues I mentioned. So this will be the same DNS service graph. It's just made a little more accessible here from the front page of the Cluster Explorer. But let's look at that all of that data that I just showed you lives in the cluster in Pixie. It's fairly ephemeral. It ages out over time. It's meant to be for those, something's broken and I need to figure out what's wrong right now use cases. So now what we want to do is look at the value that New Relic can bring using our integration with Pixie. So we're able to ingest some of these metrics like HTTP spans and some of the database queries into New Relic's platform so that you can store them longer term. You can trend off of that data. You can put it into dashboards. And that's what I want to focus on for the second part of this demo. So let's go ahead and look at my catalog service in the Cluster Explorer. You can see here, I've got pod information container. CPU and memory consumption. But then I see that because of our integration with Pixie, we've recognized that there's a service running in here. And I can see response time, throughput, and error rate for the catalog service. So this check metrics with Pixie will get me directly into a slide out that shows me the raw data living in the cluster. But if I click on See Service Details, this takes me over to New Relic Explorer. So now I'm looking at an open telemetry service that we have synthesized as part of our platform. And now I get longer term access to this data. I can look across clusters. So I know for a fact that I've got this service running in multiple clusters in this account, and I can facet on or group by that cluster name. I get related information here on the right-hand side, so I can see that this service is contained in a sock shop workload, and it is called by my front end. It's part of these two clusters, and it's hosted in these two pods. So this gives me really good contextual information about this service. If I look at, for example, orders, I've got some alerts set up that are in an alerted state. I can see those alerts here in New Relic in the activity stream in the upper right. So I have the ability to drill into those alerts and do some triaging if I need to. And then, very similar to New Relic APM, transactions. So you can view, say, your orders endpoint and the response time, your percentiles, 99th, 95th, median and average here in the New Relic Explorer Services Open Telemetry view. And then also, we are not fully integrated with distributed tracing yet, but that is something that we would like to do in the future. So you'll see traces show up here. These are just individual spans. These are those HTTP requests that I mentioned Pixie is able to trace using EBPF. So you'll see those start to show up in the places that you would expect in New Relic's UI. I think that's it for this overview. So this is just an example of a single service where we're able to see that data in New Relic. It's accessible using NERCL. So if I look at the queries behind some of these charts, if you're familiar with our query language, then you should be familiar with this syntax, but we're essentially just looking at HTTP server duration is the attribute name for this metric. As part of that integration, you can then take advantage of a new capability in our platform, which we call instant observability. So we have a lot of solutions that we've built that are combinations of dashboards, pre-configured alerts, and other things that are now made searchable as part of this instant observability catalog. So you'll notice that we have a Pixie quick start is what we call it in here. So you as a customer have the ability to install this dashboard, and then we also provide you some pre-configured just example alerts that get you up and running quickly, and then you can customize those as needed. But that install process would look very similar to this. You would click on the begin install. Maybe you've already got Pixie up and running in your cluster, and then you have the ability to directly import whichever components you want as part of New Relic Instant Observability. And then that gets you to this. So now I have a Pixie dashboard that's aggregating this data across my entire account. I may have Pixie running in multiple clusters, and I can start to look at things from a little bit higher level. So we really got into some of the details using the live debugging tab, but maybe I just want to look at the response time of the top 20 slowest services in my cluster. So I've applied the filter in this dashboard to my cluster name. I can now see those services running here and the response time over time. Maybe I want to just dive into the errors. Sure enough, there's those 500 errors that I generated as part of the demo. Maybe I want to filter down to this pod, and let's go ahead and filter down to this status code as well. So now we're really drilling into some of the details here for the data that we're now ingesting into New Relic. And you'll see this tab at the top, HTTP spans. So I mentioned, we ship this data to New Relic for longer term storage. You can now put this side by side with, say, your infrastructure metrics, or maybe you've got our Kubernetes integration running as well. But here are the raw spans that Pixie was able to detect using eBPF, and then through our integration, we pulled them into New Relic, and now you have them available to you in dashboards. So that's, this is the example Pixie Quick Start dashboard that you would get as part of that instant observability install that I just walked through. Hopefully this gets you up and running quickly. It at least gives you some example queries to work with, and you can customize this experience as you see fit, but we feel like this will be a good resource to get people acquainted with Pixie and how to leverage this data in New Relic. I want to be cognizant of time. We have about 8 minutes left, and I want to end with one final thing, and then I'll try to address some of the questions that I'm seeing coming up in the chat. Workloads. I mentioned a feature called workloads in my presentation. We're excited about some of the capabilities that it brings to either ops SRE teams or developers, but you can think of a workload as a grouping of related entities that might be supporting a specific service. And so in this example, actually, let me switch to a different browser because there is a beta feature that I want to call out here. So you'll see that I have a list of entities in this workload. We have my Pixie services. We have the Kubernetes pods that those services are running in. We have Kubernetes deployments and hosts that make up the Kubernetes cluster. This could also be things like Nginx ingress. It could be some of your load balancers running in AWS. All of the components that might be part of the overall service that you're providing to your customers. And we're able to dynamically generate these workloads using tags or other metadata that New Relic's able to see. So you can see here on the right-hand side, I've provided some tags to build this workflow based upon, either entity types, account names, cluster names. This could be AWS tags. This could be Kubernetes labels. But it makes this dynamic so that if you're onboarding new services or new components, those will show up here automatically in the workload view. We have an activity overview that gives you some of the golden signals for the different entity types that make up that workload. So here on the right-hand side, I have all of the alerts that might be happening for any of the components in my workload. And then I have, some high-level visibility into metrics or some of the key signals for some of those components. And then we have the ability to link to dashboards as well. So maybe that next step is when I identify a problem or a spike, I go to that Pixie dashboard, or maybe it's a custom dashboard. And then finally, we have a brand new feature around service levels, SLOs, SLIs. And I've built some examples here using those Pixie services. So we see my catalog service and my order service represented here. I've built some SLOs around error rate and latency. My catalog service is doing well over the past day. It's well over my SLO target of 95%. I have low expectations. I'd love to go for 99.99, but this is a demo environment, so things happen. But this gives you an overview of your attainment over time. And then, sometimes things aren't so good. So we dug into some of the errors around my order service, and I have a lot of errors, so my error budget is completely blown out. And that might be something that, me and my team might want to go investigate improving in the future. So there's been a lot of information in this session. Just to recap, let me go back to my slides and we will get to some questions here. Essentially though, I've lost my slides. Bear with me. So to recap, we looked at the live debugging tab in the Cluster Explorer. We drilled directly into the raw Pixie telemetry data there and walked through some troubleshooting scenarios. We then backed up and we looked at the telemetry being acquired through New Relic's integration and how it can be used in dashboards and workloads in the New Relic platform. And we finished with a brand new beta feature and workloads around SLOs and SLIs. So that encompasses really the basics around Pixie and where we're at today with the solution. We have a lot more planned. There's a lot in the roadmap around Pixie, but we're excited about the capabilities that it brings to our platform. And we're also excited about the fact that it will remain a CNCF project, and it's continuing to expand in the open source world as well. So what I'd like to do is just go through some call to actions, and then we'll get to a question or two. Just to conclude, go out, learn more, attend some of the related sessions. There's two specifically that I'd like to call out. One is around advanced Kubernetes observability with Pixie. Hannah's going to get into some pixel scripting and creating custom scripts to acquire certain types of data in your cluster using the pixel language. Super interesting stuff. And then Brian and Daniel are actually going to be delivering a full-blown workshop. So it's almost 2 hours long. Observability with Amazon EKS and Pixie. You'll have access to an EKS cluster. You'll deploy Pixie. You'll deploy a demo application. It'll be broken. You'll get to go use Pixie to troubleshoot what's broken and hopefully uncover root cause there. So look for those in your agenda. Please go and visit them if you have the time. And then finally, 2 and 3, if you have a cluster in your environment, install Pixie, install the quick start, investigate what value it can bring to you there. And then if you have questions, if you need help, if you have a New Relic account team, reach out to them. They're always happy to help. If you don't, maybe you're brand new to New Relic, discuss.newrelic.com is a good place to start for any assistance you might need. So I'm going to take a look at the chat with a couple minutes that we have left. Thanks again for everyone attending. I see a question about how PII data is protected. Very good question. Pixie just released I forget the exact name of the flag in the Helm chart, but you can essentially obfuscate some of the sensitive columns, like say request headers and request body, from those HTTP calls that Pixie is able to see. There is a roadmap around that as well on making that more flexible so that some of that potentially sensitive information can either be excluded or obfuscated. So there is a mechanism in place today in Pixie to account for that, and those capabilities are going to improve in the future as well. Looks like Vihang already answered that, so I'll defer to him. He's the expert on the Pixie side. And I don't see any other questions. I think that might be it. If there's anyone that wants to jump on the mic, I think the mic is open. I'm happy to field a live question or two with the remaining minute or two that we have left. No live questions, that's okay. I'm not typically a live question guy myself. So we'll go ahead and wrap things up. Thanks again, everyone, today. This was just really meant to be a basic overview of Pixie, the open source solution, and then Pixie and New Relic and the capabilities that we can provide you. Thanks again for attending Data Nerd Days. Check out some of the other Pixie-related sessions, and we'll hopefully see you in a future Data Nerd Days on down the road. Thanks again, everyone, and have a fantastic afternoon.